this? Can you hear?
Yes, sir.
Before you cannot hear?
No, we cannot.
Okay. I will remove this. Now it's okay? Okay, so okay, so I will discuss with you today. Can you see my whiteboard? Okay, so our data, okay, consists of qualitative, and quantitative. Yeah? Quantitative, yeah? Qualitative and quantitative. So qualitative data means you have nominal, okay, or ordinal. Right? In quantitative, you have either interval or ratio type. Okay. So all your data analysis is based on understanding, okay, that you have a different type of data, okay? And the best data is, of course, you have a quantitative data type, okay, and if you have a qualitative, either ordinal or nominal, then you need to have different type of data analysis. Okay, so today we will discuss about filtering and correlation and regression. So basically what we are discussing today is only for quantitative data analysis. Okay, so next time we'll discuss about machine learning. That part we will discuss about both qualitative and quantitative. Okay, so remember, today our data must be quantitative. Okay, I will start with sharing my screen about correlation. Okay, this is the things we discussed before midterm. I hope you still remember. Okay, so suppose you have data like this, right? And what you will do is you center the data. So how do you center the data? Is by subtracting each variable of the data with the mean. Okay, when you center the data, mean this centered data will have zero as the origin of the data. Okay, so here, this is my pen, or maybe I will use this. So here, this is the 0, 0. Okay, this is the same data, but when you center, that means you subtract its data point with the mean. Okay, then the center data will have 0, 0 as the mean, right? And we demonstrate that using Excel last time. Okay, so the effect of centering data, that means the mean of the centered data will be 0. So this is just shifting the mean, but the structure pattern of the data will not change. Okay, and next is we can also have what is called correlation. Okay, So this is an index between numerical values, which is quantitative data, so either interval or ratio. Okay, and if the correlation is between 0 to -1, okay, that means you have negative correlation. And if you have 0 to +1, that means you have positive correlation. Okay, so if you have no correlation between two variables, then basically this is called orthogonal. Okay. Why this is called orthogonal? Because correlation is basically can be seen as an angle between two factors. Okay, so how is it? We will discuss in a moment. Okay, so this is the example of positive correlation. You see here, positive correlation means the larger the input x, okay, will be also larger the output y. Okay. Now, negative correlation, on the other hand, that means the larger your input x, it will make the downtrend, okay, on the output y. Okay. Now, if you have many variables instead of just two, then you can create what is called matrix. Okay. So again, all your data will be formed into table, okay, or matrix. Okay, and each row represent one data, and each column represent the variable. Okay. And then what you will do is, from this data point, you will minus with the center for each column. Okay. You will get a center data, and then you can calculate the covariance simply by transposing the center data, and then you multiply by itself. Okay, and then you scale it with the number of variables. Okay. Now, covariance is basically the variation, okay, between variables in multivariate way. So, zero covariance means lack of any linear connection between two random variables. Now, if you standardize this covariance, okay, you will get what is called correlation matrix. Okay, so you can get the correlation matrix by taking the covariance. S here is the covariance matrix. Okay, and then you multiply by the square root of the diagonal in two sides. Okay, so this is the example. You can use Excel. Did we have a practice of this last time? Yes or no? Probably we did. Right? So you suppose you have this kind of data, okay? And first, what you will do, you center the data, and then you can start to compute the covariance matrix. Okay, and then after that, you can also calculate the correlation matrix. Okay, now if you have the data, say two variables like this, x and y, okay, so each row here represent a point, right, in what is called variable space. So variable space mean you have each column here, x and y, okay, is actually an axis, right? So then its data point here, okay, is actually the row in this data table, right? And then that row can be represented by a vector from the origin to that data point. Okay? So remember, this can only happen if you have 0, 0 as the center, right? That means your data must be centered first. Now, another way to think of the data is to transpose. Okay, that means now instead of its row as a point, now you can think its column as a point. Okay, its column as a point. So that means you have what is called object space. Okay, so the number of vector in here now become the number of variables, and one point is represented by a vector from the origin. Okay, and then you can measure from the origin. Okay, again you are working with the center data. Then you can create that vector. Remember, vector represented by the length and the angle, right? So how do you get that vector is depending on the length. So this length is represented by relative standard deviation, and the angle is represented by the correlation. Okay? So this is an example. So if you have two variables like this, right? And first what you will do is you center this value, and then you get the standard deviation of x and standard deviation of y. Okay, and you also calculate the correlation among that. Okay, what will happen is now you get the relative length. Okay, so if you see the standard deviation of x is 2.1, the standard deviation of y in here is 15.1, that means y is about 7.3 times x, right? The length of this symbol is norm. That means this is the length. So then you can represent this table into two vector, okay, x and y here, okay, and the angle between two vector is represented by the arc cos of the correlation, which is 28.9. So up to here, is there any question? Can you understand what I'm talking about or not? Can you open your camera, please, so that I can see your reaction? Is there any question? Did you get it or not? What did you get? Tell me. What did you understand from my explanation above? Amira?
It can only be measured for qual
Quantitative data.
quantitative data,
And
and then it must be 0 for the middle.
yes, and then
And then, wait. I don't really get it there for the other.
you
I don't really understand for.
For the other part, you did not understand. Okay, so
Yes, the covariance part.
okay, uh, do you understand standard deviation, right?
Yes.
Okay, do you understand what is called variance in one variable?
Yeah. Yes.
What is variance and what is standard deviation? Can you tell me? What is variance and what is standard deviation? What's the difference? What do you measure in variance and what do you measure in standard deviation? Anyone can help? Oh,
I guess standard deviation measure the dispersion of the data.
okay. Standard deviation represents the dispersion in one variable of the data, right? Now, the question is now if you have more than one variable, how do you measure that kind of variance? Variance is represent the dispersion of the data. The problem with variance is it is quadratic, isn't it? Right? So meaning the unit is square. Okay? For example, if the unit is meter, now suddenly your data is actually measured in meter, suddenly become meter square, right? Then you take the square root of that, you get the standard deviation, right? So standard deviation is basically the dispersion in the same unit as your data, right? Now, if you have more than one variable, okay, that measure of the same measure of dispersion, okay, if between two variables instead of one variable, is called covariance. Okay. Now, if you have two variables and the same measure of dispersion as the standard deviation is called correlation. Is it clear now? Okay. And that correlation is actually even better than standard deviation now because that correlation is as a value index between -1 to +1. Okay. Is that clear or not? So what is the meaning of -1 and +1? Right? So that means, okay, your data points, I will share my whiteboard now, clear everything. So if you have a positive correlation, that means your data point is creating a linear, okay, which is something like this. So this is called positive correlation. Okay. Now, if you have negative correlation, that means, okay, your data point is something going down. Okay, so creating this kind of correlation. Okay, so if this is your input, okay, and this is your output, positive correlation means your input is higher, your output is also higher, right? Negative correlation, that means your input is higher, the output is lower. Okay, so similar to standard deviation, which is only in one variable, measure of dispersion. Now you measure the dispersion between two variables. Is this clear or not? Is there any question? Now, I come back to my whiteboard. Okay. Now, if you have a data, right, you have row and you have column, isn't it? In your row, that means this is the object, okay? And this is called the variable. Okay? Our agreement is every row represents the object, every column represents the variable. Okay? Now, there are two views now. Okay? There are two ways to represent this as vector. Okay? One way is to use the one that you are usually point out, okay? Which is each object is represent one point. Okay? So this is the variable. So for example, this is the x and the y. Okay? And then each object here represent one point. So one point represent one row, right? So in that case, okay, I can create a vector, okay, from the origin to its point. So this is one way to represent data table into vector. Okay. So another way is to use, instead of doing this, okay, now I'm not using the variables as the axis here. Okay, what I'm using is, now I have a data table again. This is the object, right? And this is the variable. Okay. Now for each variable, I will represent this as a vector. Okay. So for each variable I represent as a vector. For example, I have two variables, x and y. Okay. So what I will do is I will represent x as a vector and I will represent y as another vector. Using this way, what will happen is now you have only 2 points. Okay. This is one point and this is another point. What does that point represent? That point represents one column. Okay. And this point represents another column here. So instead of one row as one point, now you have one column as one point. Okay. If you represent the data this way, okay, how do you get? You get the relative length, okay, which is the standard deviation. Say you set this as 1, for example, and then the length of this, of y, is the standard deviation of y divided by the standard deviation of x. Okay, and then the angle between vector represented by the arc cosine of the correlation between the two. So, in summary, you can represent data as either rows or you can represent data as column. So up to here, is there any question? Give me comment. What did you learn? Give me feedback.
Me, sir.
Yes. See?
So, sir, I was actually kind of confused with the variable as a factor. So basically, how do you determine the direction of the vector itself?
Okay. Because this is relative, right? Okay. Let's practice. If you still confused, let's practice. Do you want? Let's open Excel. Okay. Okay. So suppose you have like this data. Okay. What you will do? First, you will calculate the standard deviation of x, and then you will calculate standard deviation of y. So for example, you get 2.1 and 15.1. Okay. Up to getting the standard deviation, is it clear or not?
Yeah, I guess it's okay, sir.
Yeah, it's okay, right? Now, this standard deviation represent the length of the vector, right? That means I will calculate the standard deviation of y divided by standard deviation of x. Okay, 15 divided by 15.1 divided by 2.1, how much? 7.3, isn't it? Okay, approximately. Okay. Now that means the length of x, the length of y is 7.3 the length of x. Okay. So that means I can put any length of x. For example, the length of x is 1. Then the length of y must be 7.3 of x. If the length of x is 1, then the length of y is 7.3. Right? If the length of x is 2.1, then the length of y is 15.1. Okay? Now, what happened is you will put x like this vector x, for example, horizontal. It's up to you, right? And the length of x is, you can set any value, for example, 1, right? And then you already know that the length of y is 7.3 of x. So this green vector represent the vector y, right? Then when you set vector, then you want to get the angle, right, between the two vectors. So what is the angle between the two vectors depending on the correlation? So you calculate the correlation between x and y, which is 0.78, 0.87, for example. Then you calculate the arc cos of 0.876 here, you get 28.9 degree. Okay, then you can change the angle of the y relative to x by 28.9 degree. So these two vectors represent the table of two variables. To answer your question, is this clear or not?
Yes, sir, it's clear. Thank you.
Clear, yeah? So there are two ways, remember, there are two ways to think of the data table. Okay, one is using column, okay, each column as one vector, or okay, another way is, of course, to use each row, okay, like this, as one vector. Okay. Okay. So let's go to the next topic. If you are clear with this, we will go to the next topic. If you don't have any question, if you have question, please go. Ask, shoot your question. So go to Lentera, get the filtering data. Get the slide of filtering data. Okay, we will practice filtering data. Okay. will share my screen now, the whole screen. Okay. So this is the slide, right? So I will just say pattern equal to filter of the data. Okay. So in many cases, when your data is quantitative, okay, either interval or ratio, right? Your data can be very noisy, very noisy. Okay. So the purpose of this lesson is how you will find the pattern, okay, of noisy data by creating what is called a low pass filter. Okay. So here is my mantra. Okay. Pattern plus noise is equal to data. Okay. And if you do what is called low pass filter of that data, you will get the pattern. Okay. If you do what is called high pass filter of the data, you will get the noise. So basically, you start to filter is to separate, okay, the pattern from the noise in the data. Okay. So in that case, your data minus the pattern, you will get back the noise. Okay. Is this easy or not? Okay. Remember, pattern plus noise equal data. Okay. And then you will have two type of filter. Okay. I call this low pass filter. Okay. That means of the data, then you will get the pattern. Okay. Another filter is called high pass filter, that you will get the noise. Okay. And if you have the data minus the pattern, you will get the noise itself. Okay. Of course, your goal is to find the pattern, isn't it? From the data. Right? Again, your data here is quantitative. Okay. So let's create a pattern. Okay, and then you add noise. Okay, so this is the example that we will do using Excel. So the pattern is sine x or cos x, and then you create a random noise. Okay, or we can create a normal distribution noise. Okay, this is called Gaussian noise or white noise. Okay, let's do that in Excel. So I will open Excel here. Okay, so I will have time, for example, and then I will have just one variable x of time. Okay, so I will start with 0. Okay, and this is supposed to be my pattern, and this is my noise. Okay, so I will call this n of t. Okay, so the time I will just add with 1, right? And this is the beginning, so I will create based on, say for example, I will create this one, cos x, okay, plus norm inverse, okay, so I will put here. Okay, so in this case I need an average of the noise. Okay, so what I will do is I will insert these 2 rows. I will get an average of the noise and the standard deviation of the noise. Okay, so for example, the average is 0, the standard deviation is 1. So this is my input. So I will put this as yellow. Okay. So then I will have a norm in first, norm in first, okay, norm in first. I need to get the probability, mean and standard deviation. So the probability I will put it as random, okay, and then the mean is this one, right, and then the standard deviation is this one. Okay, so let's make it variable. So I will put this as IVG, and then standard deviation here I will put it as STT. Okay, so again I will change this to AVG and STT because I already give the name, right? So if you look at this, every time I press F9, okay, the noise will change, right? Now, now the pattern is cos of the time, right? So the time is t here. So I will put cos of time. Okay. I can put dt 0.1, for example. So I will put this as dt. So this time is plus dt. So I copy down, okay, this one also, I copy down, and now I will have my data, which is, remember what is data? Data is pattern plus noise, okay? So I will call this y, e, okay, so it is pattern plus noise. Okay, so this is my created data. So I will color it differently. So this blue. Okay, now I will draw. Right, I will draw using scatter plot. Okay, you see here, this is the blue part here is the pattern. You see the cosine, right? And then the orange one is the noise, and the y is the one that we want. Okay, which is the data point. Okay, can you make it something like this? Can you practice? Can you make it on your own? This is just creating data.
Sir, can you help me, please?
You open you share your screen.
This one, sir.
Yeah, okay.
I cannot follow you starting from the pattern one.
Noise is okay, right? Okay, so the pattern you can add DT. You can create DT on the top. For example, in B2 you type DT delta T. Okay, so say you put a 0.1. In C2 you type 0.1. Okay. okay, and name it as dt so that you, okay. Now in the time, P9, so then equal a previous cell, which is P8, equal P8, right? No, not that one. That is okay. That is 0. So in P9, you type equal P8 plus dt. Okay, enter. And then in C8, you type equal cosine or sine cos of P8. Okay, very good. Then you copy down. The T also you need to change. The time also you copy down. Right, and then the data is just the noise plus the pattern. Copy down also. Right, and then now you can plot, okay? You can plot the time up to the data. Yeah, the whole thing is, you can just plot. Insert scatter plot. Okay. Yeah, just scatter plot. Okay, so this happened because you can see the pattern, the blue part, right? If you want to get better, you can change the dt because your data is not so much. So say 0.5, for example. Can you see the pattern? Starting to create a curve, right? Now, you can change the standard deviation smaller, for example, so 0.1 or 0.2. So then you can start to see the noise, and the pattern and the data is not so much different. Can you see that or not?
Yes, sir.
Okay, so the noise depends on your standard deviation. Can you see that or not? Okay, so the dispersion is actually creating that noise. Okay. And if your average is actually not 0, you will create a trend. So up to here, is that okay or not?
Sir, for the graph, we use scatter graph.
Yeah, you can use a scatter plot. Okay.
Okay. Thank you, sir.
You try and show me what you make so that I can make sure that you are okay.
Okay, wait.
No, okay, very good. So now you see, okay, you can see the pattern, right? The blue one, right? And you can also see your data point, right? The Y. Okay. In reality, what you have is actually only the data, isn't it? You don't know the pattern, you don't know the noise. Is that correct or not? What you get, what you observe, okay, from the reality is the data, which is the Y there. Okay. Now, you want to create back the pattern inside that data. How are you going to do that? Okay. So in this example, I created data from pattern and noise. Then you know, okay, this is the pattern, this is the noise, okay. But this is artificial data, isn't it? In reality, what happened is, what you have is only the data. You don't have the noise, you don't have the pattern. Correct or not? Okay, so can I share my screen now? Okay. So this is the noise and the data. Now what happened is I deleted. Okay, I will create I will copy this. Okay, and then put it here. Okay, so this is the pattern. So with pattern, okay, plus noise equal data, right? Now in here, I will only get my data without the pattern. So I will delete this pattern, okay, and I will also delete this noise. Okay, if you look at this is my real data example. Okay, it look like this. Okay, this is my real data. It look like this. You don't know the actual pattern. You don't know the actual noise because they are mixed up between pattern and the noise. Can you see, is there any pattern in here? Not really, because why you don't see it? Because the noise is very big. Okay, let me change this up. Control X, I will put it up. Okay, I don't need this one. So I will. Now, if I change this into 0.2, for example. Oh, my data, can you see my data here? Okay, it's creating a kind of pattern. Okay, very close. So if I change this to 0.5, again, there is some kind of pattern, but the noise is quite big. I cannot see well. Okay, now how do I get back the pattern from the data? Right? So that is the today's lesson. Okay, how do you get the pattern or the noise, okay, from the data? Okay, to do that, what you will do is you create what is called low pass filter. Okay, so this is my screen shot of low pass filter. Okay, there are many low pass filter in the world. Okay, one is just a time average. Second is just a moving average. Or we can also use a first order low pass filter called EMA. Okay, so this is exponentially weighted moving average. Or we can also use Butterworth filter with the second order low pass filter. Okay, let's do it one by one so that you will understand. And then we will apply this to our data. Okay. So let's copy this formula here into my Excel so that we can get the whole thing. So let's go to the Excel. So this is my formula. Okay. Maybe I should put it here. No, cannot. Format. How to fit the weight? No. Not wrap text. Okay. Oh, what happened? Why the formula become very complex? Supposed to be very easy. So time average is basically, you can use recursive like this. Okay. So what is this? This time average, it depends on the time, right? So I will just use a time average. The Z is represent the data, okay? And T represent the time. And this is the previous data. Okay, let's do that. So what I will do is I create what is called, so I will do a filter here, filter, filter, okay, I don't know why suddenly become a different color. Okay, so I have a time average. So what is time average? Time average of the data. Okay, so filter of the data. So let's do the time average. How do you do time average? Initially, I will copy the data, right? I'll copy the data, and then time average is t minus 1 divided by t, right? So I will have t, okay, this t is different. So I will create a 0 here, plus 1. The t must be discrete, so I need to put it as discrete. So here is t minus 1 divided by that t multiply by the previous time average plus, okay, that data divided by t. Then I copy. Okay, so let me put the t here so that I can plot. I will put it this way. And then now this t I will put it this way. Okay, now I can plot here. Oh, can you see? Okay, so this is the data plus pattern. Yeah? Time average pattern. Time average pattern. So the blue one is the data. Okay. blue one is the theta, and the time average pattern, okay, not exactly the same as the theta, but it's actually better. You can get approximation of the pattern. Okay. Say, for example, if your standard deviation is very big, 2, for example, okay, initially is very bad, you see, and then eventually the time average pattern will getting better. So I will stop share now, and now is your time to share your screen. Anyone want to share screen?
Sir, what is the formula for time average again, sir?
Oh, it's in the slide. Can you check the slide? The formula is in the slide. Sharing the slide. Here, can you see it?
Oh, yes, yes, sir.
Okay, but this t in here must be discrete, so you just make a new t. Because t in here represents the number of data.
Oh, can I show you my Excel, sir?
Oh, sure, sure. So initially in the 8, can you click? Okay, initially you click copy, and then what you have? F9, where is F? No, no. T, you need to create a T. Yeah, that one. Equal to parenthesis, open parenthesis.
I'm sorry, sir. What did you say?
Open parenthesis. Open parenthesis.
Oh, oh. So,
Okay. And then T, that E9 minus 1. E9 minus 1 divided by E9. Okay. Multiply by the previous time average, which is 8. No, the previous time average is 8A. 8, yes, correct. Plus the new data point, which is F9 divided by E9, the time, T. Okay, enter. Okay. So then you can, okay, now you can plot, okay, T, your data, and your time average. Scatter plot. Yeah. So if you want, you can create a longer data point so that you can see the actual pattern of the cosine, or you can change the dt 0.5, for example, or 1. dt you can change to 1. Your theta is too little. You can copy the whole row and then copy down. Yes. There. When you plot, you can see better. Okay. Why you don't have your data? Can I see your average? 0 and then 0.5. That's strange. Okay, your dt, can you change to 0.1? Oh, that's strange. Why you did not have a cosine? What is your pattern? Cosine of p, that is correct. Is that copy down? Okay. And the data is the pattern plus noise. Oh, that's why. Copy down. Nah. Okay. Now we can see, right? So you can see the time average is actually helping. Okay, this one you can see. The time average is actually helping to find the pattern from the noisy data. Okay. So when your noisy data going up, okay, your time average is also going up. Okay. When your noisy data is going down, okay, the time average is also going down, but there is a delay. Okay. Again, when your data is going up again your time average is also going up with the delay. Can you see that or not? So at least you can get the pattern even though there is a delay. So give me your feedback.
Oh yeah, sir. So we use the time average when we only have the theta, right, to know the pattern.
Correct.
Oh yeah, I get it, sir. I understand. Mm-hmm.
So in reality, what you have is you don't have the pattern, isn't it? You don't have the noise in reality. Okay, what you have is only the data. Then you want to get the pattern back from the data, right? What you have is only the data. You don't have the pattern. So you want to get the pattern. Is this clear or not?
Yes, sir. Thank you.
So if you understand, can you go back to the slide and then go to the next low pass filter? Okay. So can you do EMA? So EMA is exactly the same as low pass filter. Okay. But we make it general. Okay. We make it general. So let me do it this way. Okay, let me clear all the drawing. So what you have WT plus 1 equal to T minus 1 divided by T times WT plus ZT per T. Right? This is your time average. Correct? Now, if you have this value, okay, so maybe I should put it this way. So if you have this value, which is 1 over T, okay, so 1 over T, okay, so T minus 1 divided by T plus 1 over T is equal to what? 1, right? Correct or not? So then, is that correct? So then I will say, okay, I can generalize this by saying that 1 over T, I will call this gamma. So then what is this? This one is 1 minus gamma, right? So that 1 minus gamma plus gamma, that's equal to 1. Exactly the same thing, right? So I generalize the time average into parameter, okay, gamma. Okay, what do we have here? Now we have WT plus 1 equal to 1 minus gamma times WT, okay, plus gamma times ZT. Okay, ZT is your theta. Okay, so this is called EMA. Okay, exponential moving average. Okay, EMA. Is it clear? Let's use this formula to create a new low pass filter. Okay. So let's do it in Excel. So what I'll do is I'll put this down. I don't need this anymore. Later I will use. So I will put this down here. So I need to create a new one. Okay, new filter, we call this EMA. Okay, exponential moving average. Okay. Oh, for EMA, I need a parameter called gamma. Okay, so let's say 0.5. Okay. Put here 0.5. And let's name this gamma. Okay. So I will have, as usual, the first time I will just use theta. just copy of the data, right? And then what is the formula again? Equal, right? 1 minus gamma, okay, multiply by the previous value of the emma, okay, plus gamma itself multiply by the data, okay, the new data. Is that clear? So then copy down, okay, up to the point, and then you plot again, right? So now let's plot again, and create a plot. Okay, so I don't need the time average, but anyway, I will just compare. So in here, I will have emma, okay, data plus emma. So this is the time average, and that is the emma. Oh, let's change this emma, okay, into line, right? So the format, oh, where is the format? I need to change this into line. So change series data type. Okay, so the emma, I will put it not as scatter, but as line. Okay. You want a smooth line or not smooth line? That's fine. Click OK. There. And to remove your noise, I will remove the time average. There. Okay. Let's put it up. Can you see? Okay. You have your data, which is the blue one, and this is the emma, which is the gray one. So your data is very noisy. So I will put less noise now in the data, say 0.2. Oh, okay. Can you see the emma produce actually when your data is not that noisy? The emma is very close to your pattern, isn't it? Oh, can you make it? And can you also share your screen? Anyone else? It's your turn. Come on. So low pass filter, okay, will help you to get the pattern, okay, back from your data. Okay, this is approximation, not exact pattern, but at least you will get approximated pattern, okay, from your data. And when your data is very noisy, okay, then the low pass filter will help you. Is this clear or not? Oh, come on. Can you open your camera, please, so that I can see your reaction? You mute and you close your camera, so I don't know what you are doing. to share your screen? So what do you think? Is this something useful or not? Okay, so
Is it like this, sir?
correct. So can you change your EMA into line so that
Oh, in the graph.
yes, and then your data time average you can remove.
Oh, oh, that's it. So this one at trend line, sir.
No, no, not
Oh.
up line. Change chart type.
Oh, change start type.
You remove the time average first.
Okay, okay.
Delete. There.
Oh, oh, it's sorry. That's
You just click one of that and then delete there.
why cannot this, sir?
You can delete only that.
Delete series.
Yeah.
Yeah, like this.
Okay.
And then
And now your EMA, can you change the type so that it will become line? You click first.
oh, okay, sir.
And then you change the chart type to line. XY, but still XY scatter but line.
XY scatter.
Yes, that one.
Hey, I like this.
Come on.
That's this one, yes, sir.
Yeah, any line. Oh, what happened?
I don't know, sir.
Are you sure you are plotting the right one?
Like this one, sir. The formula.
The formula is I8 plus F9. That's correct.
Yes.
And then you copy down that one.
Yes, I copied down, sir.
Okay. And then, so you can move the time average into another column. And then you just
Oh,
the whole, you can move that to another column so that
oh, maybe here.
there, yes. Oh, move.
Oh, sorry, sir. Oh, yeah, wait.
Control X, Control V. Only that column.
Wait, it's a Control X, Control B.
V.
Oh, V.
Yeah. Control,
Oh, it's a
and then you move to another column and then put as Control V. Okay. Now you can move your EMA near to your data. Just your data points. So from 6 to down.
oh, yeah, it's a
I6.
oh, I6. Okay.
I6. And then you press Shift and down.
Shift and down.
Shift and down.
Oh, Shift and
No.
wait, sir.
You while you're holding the Shift button and then N, END, N, and then down.
Shift
And there is
and
down arrow.
like this. Sorry, sir, I don't know.
there is a button in your keyboard called N,
Yes.
right? And then there is an arrow down. So if you use that, it will
So this one
move
comment
to,
X
yeah, column G.
like this.
Okay, and then now you can plot T. No, T.
Oh, that's
Your plot must include T.
oh, this one.
Yes, T and okay, going down the whole thing. And you plot
Insert scatter graph.
another plot. Okay, now you can see.
Oh, oh, so this one.
And
And
that is
then
Emma with the data, right?
yes, yes. So oh, the filter. Oh yeah, the Emma is the orange one.
Hmm.
So
That one you can change
start type
to
this one.
X, Y, and line. Oh, nice.
Oh, okay, sir. So this one is
You can
Emma.
just change the top, the chart type become Emma.
Oh, this one is so data and Emma.
Mm-mm. So I don't know which one is better, the Emma or the time average. Different, right?
Yes.
Both are creating pattern for you, okay? And the nice thing about Emma is now you can change. Okay, instead of 0.5, now you can change into, say, 0.9. What will happen? The gamma, can you change the gamma? Put it up, and then you change 0.9 gamma. Oh, what happened to your Emma plot? You can drag the plot of Emma up so that you can see. There is an error. I don't know what is your error. Oh, your Emma is now close to your data point, right? Very close to the data point because it's 0.9. How about if you change to 0.1? Okay, now check your Emma. What will happen? Oh, hmm? Now it's better. Okay, your Emma represent similar to the time average, but closer to your data. Correct? Okay, your first point is a little bit strange, but anyway, you get the pattern out of your data, isn't it?
Okay, thank you, sir.
Hmm. So, how about the others? Can you share your screen? Is there any question? Is this clear or not? Tell me what did you learn? Come on. Jonathan Bitono, Josephine, Angelina Nikita. So is there any question? No? Eunice. Oh. Is this too fast or too slow? I don't know. You give me feedback. What did you learn? In reality, okay, in real world, what you have is only data. Okay, you don't know the pattern, you don't know the noise, correct? So then you want to get that pattern from your data. Okay, so low pass filter is one of them. Okay, those who have finished with the EMA, you can continue with the other filter. Okay, you can check Butterworth filter or moving average. Okay, I will give example of moving average. Okay, Butterworth you can do on your own. Okay, so I will put moving average. What is the MA? Can I show you my screen? Okay, so I will create MA3 and I can create MA5. Okay, so MA3 is easy. What I will do is I will take the average, right? I will take the average of the tree. Okay, this is your data, right? Oh, the three last. Sorry, so in this case, average of the last three data. Okay. MA5 will take the average of the last five data. 1, 2, 3, 4, 5. Okay, the last three. So then copy this down. And MA5 and put this down. And then let's create the plot. Okay. Let's create the plot. There. If you want to compare, you can compare. The time average is the most sluggish. You can see the time average here is very slow to respond. So I will just delete that. Okay. So this is now I will have data plus MA, okay, moving average. So the EMA Control V there. Okay, so quite close between the so I will remove the M. Okay. So moving average is also another way, okay, of filtering your data point. Okay. to create the pattern. Right? Again, the larger your moving average, the larger the delay. Right? And you will get similar pattern to your data. Okay, let's do a pattern of your data like this. Okay. And then I will change the chart type. Okay, MA3, I will put it this way. Also line for MA5. Oh, can you see? There is a pattern. Gamma is 0.1. Okay. So now we can compare. Okay, using MA, okay, you will get smoother pattern here. Okay, using moving average, the pattern is rich. So it's up to you which filter you will use. In fact, you will try all these filter. Huh? Okay, so you want to try? Anyone want to share your screen? Okay. So your practice today is, okay, filter your generated data using low pass filter to get back your pattern. Okay. So after you get back the pattern from the low pass filter, now you can you get back the noise. Okay. So data minus pattern equal noise. Okay. You can also do that. Okay. So another way is called high pass filter. So another way is to make a high pass filter. Remember our mantra here. Okay. High pass filter of the data equal to noise. If you want to get the pattern, okay, so data minus noise equal to pattern. Okay. Okay, so once you create the high pass filter, okay, then you get the noise, right? And then you can get the pattern by minus, okay, data minus the noise equal. Okay, let's try high pass filter. Okay, you have another value of gamma here. So I call this gamma into alpha so that you will have the difference between high pass and low pass. Okay. So you have the parameter, yeah, say I will call this alpha minus the previous one plus 1 plus the alpha divided by 2, okay, minus the current data, okay, and then we have minus here 1 plus the parameter divided by 2, again the same, okay, and the previous data. Okay, so let's do that. So now I have high pass filter. Okay, high pass filter. Okay, and then this is supposed to be the pattern. Okay, equal to theta minus high pass filter. Okay, so this is basically noise. Okay, high pass filter means noise. So for this purpose, I need to create another parameter. So I'll call this alpha. Again, I can.
Sir, I'm sorry. I think your share screen still sharing the PPT slide.
Really. Okay. So I put 0.5 again. Okay, and let's name this alpha. Okay. Can you see?
Yes, sir.
Okay, so what is the formula? Alpha, okay, multiplied by the previous value. So in that case, I need to initial value. So the initial value is the same as your data. Okay, the first one equal to the data itself. Then equal this alpha multiplied by the previous value, right? And then plus, what is the formula? 1 plus alpha divided by 2. 1 plus alpha divided by 2. Okay. Divided by 2. Multiply by what? Multiply by the current data. Right? And then minus again. This one minus. Again 1 plus alpha divided by 2 again, multiply by the previous data. Okay, previous data. Okay, so I get that. And just copy, right? So I get the noise. And then, what is the pattern? The pattern is equal to the data minus that noise. Okay, and then I can start to plot again. Okay, I can start to plot again. There, I need to delete the time average. I delete the so this is pattern from high pass filter. So the pattern from high pass filter. So I need to remove the EMA. I need to remove the moving average. So how to do that? I'll make it bigger so I can get the data with this yellow. Delete. Oh, where is that? Green one is the high pass filter. No, the EMA I need to remove. Okay, the pattern. Is this the EMA? No, this is the data. Where is the EMA? Anyway, so let me copy this, going up. Okay, so this is the pattern from the high pass filter. I can change this, okay, so that I can see clearly. So 0.2 here, and alpha is 0.9. Okay, now I can get back. MA, where is the MA? There. Okay. Now, can you see the pattern from the noise? The green one is the noise. Okay. And the blue one here, maybe I should change this to a different color. Format data. The marker, I will change this marker to red so that you will see. Okay, so that pattern is the one that in red. Okay. So again, I can get back from the high pass filter. Okay. I can get back the pattern from the high pass filter. Okay. Simply by subtracting, simply by subtracting the actual data, okay, from the high pass filter. Is this clear or not? Okay, so you have learned about low pass filter and high pass filter. So what do you think? Okay, now your time to share your screen.
Sir, how is the formula again, sir, for high pass filter?
Check
Sorry.
check the slide.
I read this, sir, but I'm confused.
You get
Is it like this, yes, sir?
the formula in the slide. Okay. So alpha multiplied by the previous value of J, correct? And then 1 plus alpha divided by 2 multiplied by F, correct? Minus, oh, that's correct. Okay. I don't know what is your problem. Why keep telling that error. And then pattern equal to data minus noise. Okay. Remember the high pass filter represent noise. Something is bothering. And then you can now plot the time. The x-axis is always the time. Okay. Oh, okay. Now you just need to delete some of that. Oh, actually you can also compare, right? By plotting all of this, you can compare.
Also delete which one, sir, from the chart?
Oh, the one that you don't use.
So the MA, Emma.
Yeah, Emma, MA, you just delete. Okay. MA, you delete. Okay, now you have.
And then create the line for
Yeah, you just put the line
pattern.
pattern, right? Is that the pattern? Yeah, okay.
And for the
Okay, the
only for the pattern.
only for the pattern.
Okay, sir.
So this is pattern based on the high pass filter. That's another way, right?
Yes. So high wait. High pass pattern.
Remember, a high pass filter will produce noise. That's why you minus. Okay.
Oh yes.
Okay.
So we can choose between all of this one.
Yeah, you can choose which one.
Time average, EMA,
Correct.
MA, and this one, sir.
Correct.
And high pass filter. But
And
which one? Yes, sir.
Which one I don't know. Depending on your data, so some are better than the others, right?
Oh, yeah. Yes, sir.
Within science, there is an art, meaning to choose which filter you will use. That is still art. So in your case, I think your high pass filter is so bad.
High pass filter is, I'm sorry, what, sir?
Your pattern, why
Yes.
pattern is not so close to your data? In fact, it's reverse. Something is wrong, I think, in your computation.
Oh, what, sir?
Maybe you add instead of minus, is it?
Oh, which one, sir? This one.
No, 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 no. In your pattern, equal data minus noise.
Oh, wait.
You already minus.
Yeah.
Why? I think something is very wrong. Okay,
The
try.
formula here is already correct, right, sir?
I think so. Oh, no, no, that is wrong. That's why.
Oh, wait.
That one is
Yes, sir.
plus, not minus. The first one. Yeah.
This one.
Yes, plus.
Oh,
Okay.
okay. So track down. Yeah.
Right. Now, can you check that again? Oh, now it's better.
Oh, yes, sir.
Right?
Yes, yes.
Yes, yes.
Okay. Thank you,
Okay.
sir.
Okay. So the pattern must be almost the same, right? Between low pass filter and high pass filter, right? The difference is only shifted to the right or to the left. Almost the same. So, is this useful for you? Do you understand what we are doing or not? The big picture. Give me feedback. What did you learn? So this is especially useful if your data is time series. No? Okay, so I want you to practice. Okay, let's create another data. I will share my screen. So I will have a time here, T. Okay, I will put it 0 plus 1. and then I will have x or your y directly, yt. So let's have mean and standard deviation. So I will put mean is 0, standard deviation is 1 for the noise, okay? And this time, I will put 100 here as initial value. And then I will put the previous value, okay, plus norm inverse, right, of random of that mean and that standard deviation. Okay, so that it will not change, I will name this mean noise and standard deviation as the D noise. Okay, so I will change this, the mean noise and standard deviation. Can you see the formula? Okay, so now I want you to get the pattern back from this data that you just created. Okay, so this is clearly noisy. Okay, I will put standard deviation is 1. I will put standard deviation 10. Then you see this is your data. Oh, your data is very noisy and not necessarily, I can put the mean 1 if you want. So there's a trend here. Right? So this is your data. Now I want you to get the pattern of that data. So this is called random walk. Okay, so this is called random walk. Random walk. So can you get the pattern out of this random walk? So that's your practice. Huh? So if you have this kind of data, what is the pattern? So anyone who can make it and show the screen first, you can claim your recitation point. How is it? Okay, so you want to go to bathroom first, so I will pause for a while you are making. So we can, how many minutes? Break.
Sir, I'm sorry, before what you asked us to do, sir?
Hmm?
What do you ask us to make the
You
time
create a
and the
random walk.
ID?
You can create a random walk and then find the pattern from a random walk.
Oh, okay, sir.
Make it. Can you create a random walk? Okay. Get pattern. Okay. From random walk. Okay, so this is the formula of random walk. It is very simple. Okay, so I will pause for 15 minutes for you to go to toilet. And some of you are complaining already. Yeah, we'll come back. So you can see your filtering work actually. Okay, from the pattern that you have, you get from the data that you have, you get a pattern that is close to your data, isn't it?
Yes, sir.
This is very nice. So for your group project, so you start to have this kind of filtering if you have quantitative data. Okay, so is this clear? How about the others? Of course, this class is not only Karen, right? Anyone want to share your screen? Okay, so is there any question regarding the filtering of your data? Can you give me feedback? What did you learn from this lesson? Lindsay,
Yes, sir.
what did you learn?
I learned how to filter the data using low pass and high pass filter.
Was
Using
it,
low,
was it
yes.
successful?
Actually, I didn't quite get like the EMA and something something, but I learned like there is like many types technique to filter the data, like yeah, like you said, time average, MA3, MA3, MA5, like that.
Oh, which part you did not get?
The EMA, sir, but yeah,
The
I
EMA you did
can.
not get.
Yeah. Yes.
Okay, can you show me what did you make so that I can help you probably?
But it's okay, sir. I can watch the recording again, sir. Actually, I tried to follow, but yeah, I lost.
which part did you lose? In which part did you lose? Is it too fast? Emma, did you, okay, maybe my point is like this. Can you read the formula and then can you implement the formula in Excel?
Well, sir, sorry, my internet is so lagging, so I cannot follow like
So
every step
when you see the formula in slide, okay, in the
Yes.
formula, right? So when you see the formula in the slide, can you implement that formula in Excel?
Maybe, yes. I don't know, sir.
How about the others? Michael, what do you think?
Some variables can be confusing, sir, if I don't see you doing that or others doing that.
Okay, tell me which part in this filtering data, can you make it or not?
For example, if I see from the low pass filter, there's moving average. I don't understand like what Z stands for, sir.
C.
Like that, yeah. That's
the Z stands for the actual data, right?
oh yeah. So like I mean when I
Okay,
just look at the presentation, yeah.
I got your problem, so I need to explain again. I will share my screen. Example here. Can you see it?
Yes, sir.
So this is the filter, right? WT is the filter, right? And then Z here represent the data. So everything with T mean current, right now. Okay, everything with T minus 1 mean previous. So in Excel is easy, you can see previous row. Right? Everything with Z here, T, that means current at this row, the same as the filter. Okay? And then T minus 1 means the previous row. Is this clear or not? So Z is the data. Okay? That means ZT minus 1 means the previous data. So one row before. Is this something that you confused about or not?
Yeah, that much is clear, sir.
Okay. So in high pass filter, can you make it? Michael, can you make the high pass filter?
I haven't tried, sir.
Okay. So Amira, how is the high pass filter? Can you make it?
I only follow previously, sir. But let me share.
Okay.
Sorry, sir, I cannot share
Oh,
because
sorry. I will close. Can you share?
like this.
Okay, so you make the high pass filter. Oh, something is strange in your data and time average as well as data in EMMA. I think the plot problem. You need to plot between the time and those data. seems like
I'm sorry, sir.
the plot is the problem, right? I think you make a wrong plot. Theta Emma, that how do you plot that? Can you go to your chart and can you make that chart closer to your data so that I can see?
Oh, okay.
Can you move that chart near to your table? Ah, that's why. You see, the T must be in the first part of your point. The first column in your table must be T, not data.
Oh, I see, sir. So T and then,
And then say you have a T and then the time average, the T and then the data and then time average and then the MA. So you just exchange the column. Can you?
oh, okay, sir. I will
Then you
change.
plot again.
Thank you, sir.
Thank you. So anyone else want to share? If you did not get it, so you need to ask, okay? You don't just rely on the recording. St. Patrick's, do you want to share your screen?
Sir, actually, I'm still trying to do the Emma one, the previous one that you just asked us to do.
Okay.
Yes, I'm trying to figure it out. I mean, I need a little bit more time to complete.
Oh, so you figure it out by sharing your screen so that we can do it together. I think if you have problems, the others also have the same problem, right?
No, I don't have any problem. I think I just haven't finished it, sir.
Okay. How about the others? Eunice, you want to share your screen? Axel. Okay, okay.
Oh, sorry, sir.
Hmm.
Actually, I'm not doing it because I need to focus on your explanation, sir. So I haven't do it the Excel because if I do the Excel while you explaining, I usually didn't get what you say.
Okay. Stephanie or Netania, I want to know, is the majority do not understand or you do understand but you just need time? Right. St. Patrick said he just need time, so he understand but he need time. So how about the others? So which part you don't understand? Jesse, where is he? Or Valencia, you want to share your screen? So what do you want? You want me to wait for you to practice, or you want me to continue with the next lesson? We have about 30 minutes. No, about 30 minutes. The next lesson is about regression. Is this too much for you, or?
Sorry, sir, but I think personally for me, I need more time to practice
Okay,
this one
okay.
because this one is not easy at all for me.
Is it not easy?
Not that easy.
Okay, which part? You need to give me feedback so that I can help you.
Wait, sir. Actually, I found the last task that you asked us to do. This one. It's all good. Wait. Can you see my screen?
Not yet. Okay.
Hmm.
Okay.
So it's basically like this one.
1 minus gamma times E4, correct? Oh, this is good. So you make it. You make the EMMA. Very good. Right? So, oh, you did. Try to make the standard deviation bigger so that you can see the risk, for example.
Okay.
Or 10 or 20.
Oh, I'm sorry.
Make it 20. Standard deviation
Okay.
20. Oh. So the EMMA still can help to get the pattern of your data, right?
Okay. I see, sir.
Can you see? But there is a delay. Can you see the delay?
I'm sorry. What?
Can you see the delay?
Delay in what, sir?
Okay. Make it bigger so that I can show you, and then make the EMMA into line so that you can see, or both point. Can you change the chart type in line, both sides, the Y and the EMMA? No, not that one. Change the chart type.
I'm sorry, sir. Here.
Close again. The chart type. Change chart type. There, up. Change chart type.
How if you I mean take control of mine.
I cannot check control of yours, so you just right click again.
Okay. Oh, this one. I'm sorry.
Yes. Okay.
And then, sir.
Yes. So make it into line, not just dot. Okay, that one. Okay, good. Click OK. Okay, make it larger so that you can see. Can you see that there is a delay? Can you see that there is a delay between your data and your EMMA? Your EMMA is following your data, right?
Yes.
But after the data, so shifting to the right.
Also, you mean it? My EMMA is not exactly what my data is, right?
Correct. So,
Yeah.
right. So there is a shifting to the right.
Okay, understand.
And you see in this particular example, I will just annotate here. In this example here, okay, your
Yes.
data point is up and down, right? But your EMMA is actually almost straight line.
Almost what, sir?
Almost horizontal, right?
Oh, yeah.
Correct. So that means the noise in this case, up and down, okay, is actually filtered by the EMMA. So the EMMA is actually filtering that data out. Okay. The same part in here, example. I give you example here. Can you see this window? Okay. Your data point is up and down, but the EMMA is slowing, following that data pattern. Can you see or not?
Yeah, I see it, sir.
When your data is actually going up, say example in here, your data is actually going up. There is a trend of going up. The EMMA is also following that, okay, using that pattern. So you can also change that EMMA, okay, by changing the parameter of EMMA. Can you change the parameter of EMMA?
This one.
Yes. So 0.1, for example. Now you see the EMMA is smoother, right? So when your data point is actually here, when your data point is actually going up on the trend, okay, and going down in the trend, EMMA is following that trend. Of course, there's a delay, right? So you see your data is actually going down here, and then the EMMA is going down there. Can you see that?
Yes, clearly.
There is a delay. Okay, and so the noise of the pattern that you have, okay, that EMMA is actually helping you to see the overall pattern. Is that correct or not? So of course, if you want better, you can change this gamma into 0.01 or 0.05. Try. Okay, so then become smoother, right? Become very smooth. But because of the smooth pattern of EMMA, the delay is so much. Now you can change the gamma to 0.9. Now the EMMA and the data is exactly the same. So in this case, you don't filter. Can you see that or not?
Yes.
So depending on your parameter, if your gamma is actually very high, say near to 1, right? In this case, the filter does not work because your gamma, your EMMA is the same as your data. Right.
I get it, sir.
Can you get it or not?
Yes, I get it.
So now what you need to do is to change the gamma closer to 0. It's not 0, 0 is error, right? So 0.1 or 0.0. Okay. That one you can see the smoother pattern. Okay.
Yes, sir. Pretty clear, sir. Thank you.
Okay. Is it clear now? So your real data is noisy. Okay. Now you want to get the actual pattern. Okay, 0.02 is actually too much, right? So probably you want to get it 0.1 or 0.2 actually to make it so to get close to, again, finding the actual value of gamma, okay, for your real world data is an art. Okay, you can see there is a pattern that you want. Okay? You don't want to be too general. You don't want to be too close to beat the noise. Okay, so I hope this is useful. How about the others? Yeah, thank you, Patrick. Is there any one want to share your screen? If you are not clear, so it's better to ask question, you know. Just following from the video, I don't think you will do anyway, right? Last time I deliberately did not upload the video and nobody complained. So meaning that they never, you never actually checked the video. Valencia, can you share your screen?
Oh, I actually did it in my iPad, sir, because my Excel cannot be open in this laptop. I don't know why.
Okay. Okay, Netanya. Are you still there? Okay, so you said okay if I continue with the next lesson? If you don't have any question, you don't have any feedback, so the filtering is finished. Okay. Let's start with the new topic, which is regression. This is very long. (100 slides). Wow. Okay, so I will start with the very simple linear regression. Okay, I hope you can make it first. After that, we can continue with the non-linear transformation and then multiple linear regression, okay, polynomial. And at the end, we can try to attempt, okay, to create regression for classification. Okay, so that after that, we can go to machine learning, okay, for classification. And from next week, I hope you can also download WEKA, okay, so that we can practice also. Okay. The link is already inside Lentera. Okay. So don't forget, huh? So I will type. Please download WEKA, download and install WEKA. Yeah? Okay. From the University of Waikato. Okay, you search in Google if you cannot find. So, okay, let's come back to the regression. So, remember in the beginning, I explained to you about three application of modeling. Okay, one is to understand the phenomena, right? And second is to do prediction, and the last one is to do what is called optimization or control. Okay. And regression is basically a modeling technique of numerical data. Okay. So the data must be quantitative. Okay. So you have equation is y is a function of x1, x2, x3, and so on. Okay, so both y and the x must be quantitative. Okay? Especially the output y, variable y, the response. Okay, this is also called dependent variable, must be quantitative. Okay? The input, x1, x2, and so on, okay, they can be quantitative or qualitative, meaning the variable in x1, x2, x3, and so on can be ordinal, can be nominal, okay, or interval or ratio, doesn't matter. But okay, the output here, the y, must be numeric. Yeah? Must be quantitative. Okay? So this is very important because later on we will have what is called classification. Okay? In classification, the output, the y here is categorical. That's the difference. Okay, so we can also think, okay, the relationship between input and output as a system. So function is basically a system. Okay, so suppose the system will receive input and produce output y. Okay, so x here is the input, the y is the output. Let's call that system E. Okay, dot mean the input. So then a system is called a linear system, okay, if the system satisfies two conditions. Okay, what is a linear system? Okay, a system is called linear if these two conditions is satisfied. Number one, the system that receives a sum of two input, okay, will also produce output equal to the sum of the input. Of the two inputs. For example, if the x is actually, the capital X here is actually equal to x1 plus x2, okay, you put it into the system, it will produce the y which is equal to the sum of its output. Okay. Number one, if the system receives a constant multiplication of the input, it will also produce the output equal to the constant multiplication of the input. For example, if your input is x and then multiply by that constant a, right, then that a must be on the output as well. Okay, so the output is ax, can be put it out. The a can be put it out of the ax. So if you have these two conditions satisfied, then that system or that model or that function is called linear. Okay, so these two conditions, okay, can be summarized into one. Okay, so for example, your input is a x1 plus b x2. So the output will be exactly like this. A times the output of x1 plus b times the output of x2. Okay, so that two conditions of the linear system can be said that it is a linear combination. Okay, a linear system is a system that produces output equal to the linear combination of the input. Okay, so the graph of this system is a straight line. So then we have what is called linear regression. Okay, remember, linear regression is linear in parameter okay, but not necessarily in variable. Okay, so look at this polynomial regression, right? So y equal to a1 times x plus a2 times x squared plus and so on. Okay, exponent of p in here. This is still linear regression. The same thing with the nonlinear. Okay, like this can be think as linear regression. So now in your practice, which of the following is linear regression? Which of these is linear regression? Can you annotate here? Can you annotate here and then you can claim your recitation point? Okay, which one is linear? And tell me why. Can you open your annotate in Zoom and then you just encircle? Which one is linear regression?
You said y equals to mx plus c, sir.
Oh, you encircle there.
What do you mean by insert, sir?
You can annotate, you know, in my slide. Can you annotate in my slide?
Oh, wait, sir, I'm confused. How to do it, yeah, sir?
Go to on the top there is a annotate menu. Can you annotate in my slide? There, okay. So you can okay, very good, Karin. So that one is linear. What else? Anyone else think that linear? That the one that Karin just annotate is called simple linear regression. That is the model. So which one else is linear regression? Anyone else? Can you annotate here? Come on, you use your tool. You can annotate in my screen, you know. Can you? Which one is linear? Aside from what Karen said. Which one is linear regression? Anyone? In fact, I'm telling you. In fact, yeah, Shane, very good. Okay, that one is linear. Okay, why? Have exponent there. Why this is linear? Saint Patrick, why did you say that that is linear?
If I'm not mistaken, I have ever had this kind of equation in my senior high, and I remember that this one is linear
Okay.
as well.
Okay, so you already learned in senior high school that this is linear. Okay, in fact, all of this model that I've shown here is actually linear model. Okay, there is none of them that is non-linear. Okay. Okay, so in this slide, in this topic, you will learn all of this, okay, as linear. So here, this is called simple linear regression. Okay, this one is called multiple linear regression. Okay, and this of these others are called non-linear transformation into linear. Okay. So let's start with linear regression first. So, remove the annotation. Okay, let's see this. Okay, simple linear regression is a linear relationship between two variable, okay, x and y. X is the independent variable and y is the dependent variable. Okay, so you already learned this in high school probably. Okay, this linear model, very simple. Okay, so this is the line of the model, right? And this is the slope. So this is 1, this is alpha or m, slope. Okay. And this is the intercept. Okay. And of course your data, so example, this is your data point. Okay. It's not exactly in the line. Okay. So, and then we measure the error, okay, based on the vertical distance between the data points to the model, to the line model. So, to give you understanding of this, okay, I have this example of 5 data points. Okay, so this is my data. Consists of year as the x, right? And then this is the y. The population is the output. Okay, say this is in 100,000 person population. Now, can you plot this? If you type this in Excel and you plot, okay, and then question is, can you get the prediction of the population, okay, 5 years from the data? Okay, so you have 5 data points. You want to predict the next point, right? So can you plot this data and then what is the best model? So if we plot this, it looks like a straight line model would be the best, right? Okay, so let's draw a line to say that this is the straight line. So I have 3 lines here, the blue, red, and green. So, okay, tell me, which one is the best? What is the best fit for the data? The blue one or the red one or the green one? And why? Huh? Are you still there? Can you open your camera? Can you vote? Which one is the best line here? The red one.
I think blue or green, sir, because the red is overfit.
What is overfit?
Like, is fit to the data. Like very, very fit.
Okay, is it? Green?
I don't know, sir.
I don't know. Why you choose the green one?
Who, me?
Hmm.
I don't know. I think the green or the blue one is like better than red, but I don't know which one is the like the correct one. Like is the best fit one.
Oh. Anyone else? Which one is the best for you? You like green. Why, Josephine, you like green? Why? Come on, you tell me. Okay. Lindsay said, I don't like the red. Green is better than the red? Oh no. Let us see. Okay. So I asked that question. Okay. Oh, the best is actually depending on the criteria, right? Okay. What is the best? Okay. So okay, so this cartoon character said the blue line, the criteria is passing the first point of the data. The green line, because it's in the middle of all points. Okay, so and then what is it? The red line because pass through most point of the data. Oh, everyone will have their own argument on what is best. Okay, because they have different criteria, isn't it? Okay, so but I think we need more objective criteria, isn't it? Right? To say which is best. So one objective criteria is to measure the error. Okay. So what is error? Error is discrepancy. Okay, between the model, which is the line, okay, and the real data point, right? So we want to minimize the error, correct? Okay, so how to measure the error? Okay, when the line is like this, okay, above, okay, if the line model is above the data, then the error is negative. Okay, when the point data is above the line model, then the error is positive. Okay, so error can be positive, can be negative. Okay, so but if you sum all of this error, okay, it's just zero because I have positive and negative. So it doesn't work. So in that case, similar to standard deviation idea, right? So variance idea, we square it. Okay. So the baseline should be minimizing the sum square of error. Okay. So by saying this is actually we are assuming the error must be normally distributed with zero mean and constant variable. Okay. So let's calculate the error. Okay. So so here I calculate the error. Okay. I square it, right? And I sum. Oh, which one is the lowest among these? Unfortunately, the red one. Okay. For you, Lindsay, actually get the minimum sum square of error. So the lucky guess is correct. Okay. The red one is actually the best line, not the green one. Okay. So of course, you don't want to get a lucky guess. So how to get that? Okay, you use formula. Okay? Use formula. So this is the formula that we will practice next meeting. Okay. Okay. So if you can try first. Okay, before next meeting. So you practice to use this formula by creating this paper. Okay. So if not, I will give you time during the beginning of next meeting. When is your next presentation? Is that next week? No. Okay, so next meeting, you will practice this, okay? You will type this in Excel and then try to make this. Okay. Or should I make this as a assignment so that you will practice at home? So that we don't waste our time in the class. Is that okay? Okay, I will.
Practice together, sir.
Yeah, exactly. So you do it at home and then we practice together by sharing your screen. Okay, so I will put this as assignment, okay? Okay, so that you can practice together next meeting. Okay, so see you next meeting then. Can you confirm first? For Monday class, big data, are you going to be online? All of you? Or is there anyone want to be in the class? If everyone is online, then I will not come to campus because now I'm in campus. Can you confirm?
Maybe we will confirm it later, sir, because we need to discuss first.
Okay. So I will wait for you, Josephine.
Sir, but if I'm choosing on the on-site on the same data, but what if later we decided to be online? Do I still count as absent or
No.
what, sir?
The option will be based on Josephine, right? Is the one who will absent for you.
Oh, okay.
Right. So for me, I prefer online, but it's up to you to decide. So if you want online, so I will not come to Petra. Why waste my gas for just changing the location, right? It's really not an efficient way to do. But if you have any one of you want to be on site, so then I will accommodate your need. Okay. So thank you for today, and please do the assignment of regression. See you.
Thank you, sir.
Thank you.
Thank you, sir.